Hi, this is King of Review. Here we have three functions, and we need to see if they can be written as shifts or reflections of y equals log base 16 of x. Let's start with the first one, y equals the log base 1/8 of x. Now it would be nice to write 1/8 as a power, since logs are all about powers. 1/8 can also be written as 8 to the negative first power. There's a property of logs that says if you have the log base b to some power a of x, we can rewrite that as 1 over a times the log base b of x. So if we use that property here, we can rewrite this problem as y equals -1 times the log base 8 of x, since 1 over -1 is equal to -1. Now clearly this function is a reflection, but it's a reflection of y equals log base 8 of x, not y equals log base 16. So a is not a shift or reflection of y equals log base 16 of x, which automatically means that choices A and D are out, since they include option A. Now let's look at B. B says y equals the log base 4 of the square root of x minus 2. Now 4 and 16 are related by an exponent, which is good news since logs are all about exponents. In particular, there's a property of logs that says if you have a log base b of x, that is equivalent to the log base b squared of x squared. So if I want to square the 4 to turn it into 16, I just have to square the square root of x minus 2. So this turns into the log base 16 of just x minus 2, since a square root squared cancels out. When you have minus 2 inside the function, that means it's going to shift to the right 2 units. So b is a shift of y equals log base 16 of x, since 16 is the base of our log. B works, and based on the choices we have left, the answer to this problem must be multiple choice B. But just to make sure, let's look at why C doesn't work. C has a lot going on in it. It has the log base 2 of the cube root of x plus 2 over 4. We can simplify it by a couple of properties, one of which deals with fractions inside of logs. This property says we can split up a fraction in a log into two different logs that are subtracted. So this turns our problem into the log base 2 of the cube root of x plus 2 minus the log base 2 of 4. Now since 2 to the second power is equal to 4, the log base 2 of 4 is just 2. So far so good, this would be a shift down 2, but we have a problem. To change the base 2 into a base of 16, we would need to raise it to the 4th power. 2 to the 4th equals 16. However, if we take the number inside the log, the cube root of x plus 2, and raise it to the 4th power, we're going to get x plus 2 to the 4/3 power. And since that's not just like x, since that's not just x, it's x to the 4/3 power, this is not a simple shift or a simple reflection, so C is not going to be a shift or reflection of log base 16 of x. If this power were equal to 1, then it would be, because the original function has a power of 1 on x, but because it's 4/3, it's not going to work, and B is definitely the only one that works. So there's our answer. Thanks for watching.